Hello friends, good evening and welcome. We are now in the last phase of plastic analysis for portal frames. Okay, we will solve one or two more problems with different variety. Then these many numericals for plastic analysis on beams and frames will be sufficient. However, you will need to do a lot of practice to see that analysis of these frames and beams using plastic analysis is an easy job for you. Okay, so practice is must. So let us start with one more different variety of portal frame. Okay, here is one single base single story frame which is subjected to one eccentric load on beam, which is here. We shall assume this is 1.5 times W, and this load on joint of beam and column is W. 4 meter is the bay, and height of column we shall assume 3 meters. One more thing, we will assume MP of columns as 1 MP and that of beam we shall assume as 2 MP. Okay, and here we have to find collapse load W for the frame. Okay, so let us solve, starting with our first step of beam mechanism. Beam mechanism for beam BC first. Again, B and C, they are internal joints, so they are assumed as fixed. And here is our load 1.5 W. We have not considered this distance of 1.5 W from B. We shall assume 3 meter and 1 meter. Okay, 3 meter and 1 meter. So this is not a symmetric loading, so rotations on both ends will be different, theta 1 and theta 2. Okay, then plastic hinge formations, fixed joints B and C, so there will be plastic hinge. Point of maximum bending moment, there will be another plastic hinge. So these are three locations of plastic hinge. Show here MP values. Now carefully show MP values on B and C. Why? B is common point for beam and column. For column at joint B we have MP value, and at same point B in beam BC we have 2 MP value. So which to be taken? 1 MP. Least of the two at the junction. Same here at C. However, under the point load there will be 2 MP values. Okay, both MPs will be 2 MP. Now this delta we have to find first. How much is delta? This is 3, this is 1. So this delta is 3 theta 1. Another value of delta theta 2. So theta 2 is equal to 3 theta 1. Simple. Now internal work done. What is internal work done? MP into theta 1 plus 2 MP into theta 1 plus 2 MP into theta 2 and plus MP into theta 2. So this is 1 plus 2, 3 MP theta 1 plus, again this is 2 plus 1, 3 MP theta 2. Theta 2 we will replace by 3 theta 1 directly. So 3 MP instead of theta 2, 3 theta 1. So how much is total? 3 plus 3 into 3, 9. Correct? So 12 MP theta 1. And what is external work done? In beam mechanism, 1.5 W into delta. What is delta? 3 theta 1. So 1.5 into 3 is 4.5 theta 1. Okay. So equate external work done and internal work done. So 12 MP theta 1 is equal to 4.5 theta 1. So how much is MP here? 12 upon 4.5. 12 upon 4.5. So this ratio is 2.67 kilonewton meter. One more thing is remaining, W, which is unknown. So we want W instead of MP, we will find W. So redo it. So 1.5 W. So 4.5 W theta 1. We want W, so W is 12 upon 4.5. W is 12 upon 4.5. So this is 2.67 and not MP. So 2.67 MP. Okay, is value of W, one value. So we will note down this somewhere here. W is 2.67 MP. Okay. Now we will carry out sway mechanism. So for sway, we need to consider horizontal load W. So here it is, delta. Okay. So here we shall assume theta 1, or we'll keep theta. So here is 1 MP, joint, again 1 MP, similar to this. Here is joint again, so 1 MP, correct? Yes, and this is also 1 MP. So from this right angled triangle, height is 3, so delta is 3 theta. Okay, delta is 3 theta. So what is internal work done? Internal work done is 1 MP theta. This is also theta, not theta 1. So 1, 2, 3, 4. 4 MP theta. Okay. External work done. External work done is W into delta. What is delta? 3 theta. So equate these two. So W into 3 theta is equal to 4 MP theta. So W is 4 by 3. 4 by 3 is 1.33 MP. So our second value of W is 1.33 MP. Now we have to carry out combined mechanism, the third one. This was our second step. Okay. So now third, I will rub this all. External work done here is 4.5 W1 theta. Here external work done is W3 theta. So now combined mechanism. This is frame in its original position, and now deformed shape or deformed position, considering both beam mechanism as well as sway mechanism. Okay, so again let us show first of all theta values. We will now assume this as theta 1, this is theta 1, this is theta 1, this is theta 2, this is again theta 1 and theta 1. Okay, so here is 1 MP, then this one 1 MP, theta 1, theta 2, here is 2 MP, 2 MP and 1 MP. Whether we are considering this one, let us see. Okay, so internal work done. So this is MP theta 1 plus MP theta 1 plus 2 MP theta 1 plus 2 MP theta 2 and plus MP theta 1. So how much? This is 1 plus 1 2 plus 2 4. So 4 MP theta 1 plus 3, so 4 plus 1 5 MP theta 1 plus 2 MP theta 2. Now we want relationship between theta 2 and theta 1, which is I think 3 theta 1. Theta 2 is 3 times theta 1, correct? This is delta, so delta is this 3 theta 1 and another value of delta is theta 2, correct? So theta 2 is 3 theta 1. So internal work done is equal to 5 MP theta 1 plus 2 MP into 3 theta 1, correct? So 2 into 3 6, 6 plus 5 11 MP theta 1 is internal work done. What is external work done? W into this delta, W into delta, delta is 3 theta 1, correct? So W into 3 theta 1, I will write directly, plus 1.5 W into this value of delta, which is 3 theta 1. So how much is total external work done? This is 3 plus 3 into 1.5, 4.5 plus 3, 7.5 W theta 1. Simple. Equate these two. 7.5 W theta 1 is equal to 11 MP into theta 1. So what is W? 11 upon 7.5. Let us calculate. 11 upon 7.5 is 1.467. 1.467 MP. So which is right value? The least value, which is from combined mechanism, sway mechanism, 1.33 MP. The least of the three is to be considered. Okay, so answer is 1.33 MP. Thank you. Hello friends, now we shall solve one more last variety of portal frame having unequal column heights. Okay, so this is the frame with simple loading. We shall say this height is 3 meter and this is 5 meter. This span, we shall say this is 3 meter, and this load is let us say 40 kilonewton, and this is 25. It is centrally loaded, so 1.5 meter on each side. MP is same throughout. Okay. So let us start solving. First is beam mechanism. So in beam mechanism, beam BC, very simple. Internal joints B and C, they are assumed to be fixed. Point load is central, 40 kilonewton. So this is very simple and straightforward. So this is delta, this is 1.5 meter, this is also 1.5. So this is theta. Okay. So plastic hinge is one here, second here, third here. That's it. At all locations we have same value of MP. There is nothing different. Theta is also same. Here is one theta, here is another theta. So internal work done is equal to 1, 2, 3, 4. 4 times MP theta. And what is external work done? 40 into delta. What is delta? 1.5 theta. I'll write here. Okay. So 40 into 1.5. How much? 60. Correct? 60 theta. So 4 MP theta is equal to 60 theta. From this, MP is how much? 60 upon 4. 15 kilonewton meter. Okay. So one part is over. Now, second step, sway mechanism. So sway is because of this 25 kilonewton force. Let us show the deformed position of the frame. So this is delta 1. This is delta 1. Now these angles will be different, not like the previous frame. Previous frames were having equal heights. So these theta values were same on both the columns. Now here this is different. Why? Heights are different. So this we shall say theta 1. This has theta 2. Okay. So we will have two values of delta 1. Delta 1 from left hand column is 3 theta 1. Correct. Another value of delta 1 is 5 theta 2. You might ask why there is then delta 1 same if theta 1 is not same, or theta is not same for columns, why delta 1 is same? Because after getting swayed, whatever is the amount by which B has gone to B dash, by same amount C will go to C dash. Okay, that is why BB dash distance is equal to CC dash, which is delta 1. It is an assumption. So 5 theta 2 is equal to 3 theta 1. So how much is theta 2? 3 by 5. 3 by 5 is how much? 0.6 theta 1. So now plastic hinge here, 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 here. So MP everywhere. Correct? So internal work done is equal to MP theta 1 2 times plus MP theta 2 2 times. So 2 MP theta 1 plus 2 into 0.6 is 1.2. 1.2 MP theta 2. Total 3.2, sorry, this is theta 1. Total is 3.2 MP theta 1. So now again equate external work done and internal work done. So this is internal work done, external work done, yet we have to calculate. So this is how much? 25 into delta 1. What is delta 1? 3 theta 1. So 25 into 3, 75 theta 1. So we will again find out MP from this. 3.2 MP theta 1 is equal to 75 theta 1. So how much is MP? 75 upon 3.2. Let us calculate. 75 upon 3.2. So it is 23.44 kilonewton meter. Okay. So from beam mechanism, MP was 15. From sway, 23.44. Now we will carry out combined mechanism. So I will show here combined mechanism. Okay, so this is delta, this is delta 1, then this is theta 1, this is theta 1, this is theta 2, and here is theta 2. So MP values, one is here, then here, then under the point load. I have explained already previously why we are not considering this theta 1 and MP. Okay, because this angle is different. So this is MP. 1 MP is here to be assumed or to be considered. So internal work done now. MP theta 1, MP theta 1 plus MP theta 2, again MP theta 2, and this MP theta 2. Okay, so total 1 2, so 2 times MP theta 1 plus 1 2 3, 3 times MP theta 2. So in relationship, we need relationship between theta 2 and theta 1. So what is that? Again, you can get from this triangle, you will get same. Theta 2 is 0.6 theta 1. Okay, so this is 2 MP theta 1 plus 3 into MP into 0.6 theta 1. Okay, so how much is total? 3 into 0.6 is 1.8 plus 2 is 3.8 MP theta 1. External work done, combination of 2, 25 delta 1, which is 3 theta 1. So 25 into 3 theta 1 plus 40 into this delta. How much is this delta? 1.5 theta 1. So 40 into 1.5 theta 1. Total 75 plus 60, 135 theta 1. So equate to external work done and internal work done. So 3.8 MP theta 1 is equal to 135 theta 1. So how much is MP? 135 upon 3.8. 135 upon 3.8. 35.53. 35.53 kilonewton meter. So our third answer is this. Our first answer was 15. Second answer 23.44. So which is correct? Highest of the three. Okay, highest of the three is correct answer. So while selecting MP out of multiple answers, you assume or select highest of the three or four, whatever the combinations we have. And while selecting collapse load, we have to select least of the loads. Okay, so now I am going to stop for plastic analysis of beams and frames. Next series I am going to start with arches, 3 hinged arches and 2 hinged arches. While solving numericals on structural analysis or any subject like structural analysis or structural design, you please remember that you need to do a lot of practice. Merely referring such videos will not be helpful while solving on your own. What you have to do is you have to refer such videos, understand and make a very good practice. Without practice there is nothing, because you may make a lot of mistakes while solving numericals on your own. How? You might take MP theta 1 here by confused because you do not have understood this concept, or you have not by heart some things. Okay, you have not kept some things in your mind. So while doing or while solving problems, do a lot of practice. Do not merely refer videos or see just videos or steps and then go for the exam. Never do such things. Do a lot of practice. Okay, so I'm waiting for you for our next series on arches. If you have any difficulties on this plastic analysis, do write in the comment section. Okay, thank you.